LSEC Technology, solution provider to financial market institutions around the globe. We provide trading, surveillance, clearing, depository solutions to over 25 institutions spread out over 5 continents.
Innovation is the legacy and the foundation of our success and will continue to be a key success factor in our future as well. We are a niche, high-performing organization with world-class talent. We attract the cream of the system in the country.
LSEG technology products win in the market due to its technical competitiveness. That is, we are a few years ahead of the competition in terms of technology. To preserve our competitive advantage, we do invest in keeping our developers abreast and up to date of all the current technologies so that in turn our products are extremely competitive in the marketplace.
We belong to a fabulous legacy which has changed year on year to be completely new, current and different. So all of us who is in this organization now and somebody who is a potential family member has an opportunity to shape, navigate, envision what it ought to be for the next centuries to come.
We have operated this company in Colombo for the last 15 years. We started in 2007, staff of 4 people, supporting one core product. And we've now grown to 85 people, supporting 15 plus products using various different modern technologies. We develop software for export only. This has given us an opportunity to bring in a steady flow of dollars into the country every month. We believe in giving university students an opportunity to work on real-world projects. As a result, we have built a very robust internship program. We have successfully implemented several CSR projects over the years, particularly focused on gender diversity. We have a very relaxed global one-office culture. We have standard HR policies across the board. We believe that respect must be shown to all fellow employees, regardless of geographic location. We believe that face-to-face interactions are very important in building business relationships. As a result, we regularly promote two-way travel programs and make it available for all of our staff on a regular basis.
Hello everyone, welcome to our LIT, the groundbreaking IT revolution in Sri Lanka. So now we are going to take you on a tour of our LIT.
Here you will get to know how fantastic team of tech-savvy IT experts transform fresh ideas into high-tech products in a fast-paced business environment. Established in the year 2010, our narrative over a decade is a journey of determination and courage. As a fully owned Sri Lankan business grown sprung from the home soil, our team is over 4,500 experts serving a reputed international clientele. In our mission of empowering humanity, Oral Labs, Oral BPM, Oral Studio, Oral Academy, and Oral Cloud are some of the business verticals we manage to deliver quality products to our clientele. We also provide a range of recreational activities such as gaming, playing music to support our employees in striking a healthy balance between on and off work times. Oral IT fosters an open culture, keeping the potential of innovation in mind. We inspire individuals to develop new ideas and make connections that will lead to growth.
So visit us and experience what makes us exceptional in the global IT industry.
The real goal of learning isn't knowledge, it's change. When we learn, we create new pathways, new circumstances, new futures for ourselves and for others. Pearson is the world's leading learning company, but what we really make, the thing we are most proud of, is change. For over 50 years, we have been transforming lives through education, helping tens of millions of people all over the world reach their full potential. And yet we are lifelong learners ourselves, forever evolving to meet the moment. With our history to ground us and our creativity to inspire us, we're reinventing everything we do, from paper to pixels, from physical to virtual. We're making learning more personal, more equitable, more powerful. There's never been a better time to learn, and we are. We are the change we believe in. We are learning.
The world has changed due to unforeseen events in ways we have not come to terms with. The paradigm has shifted. Where business as usual was good enough, but good enough is no more. How we live, how we travel, and importantly, how we do business will never be the same again. Are you driven by change? Change has become exponential. Disruption is the new normal. Business must differentiate if anyone needs to be relevant, and the growing demand for an innovative, quality, and a memorable service is high. The service is often the brand and the need. We understand this, which propels to the transformation to digital and the profound impact. Everyone wants a better service to operate better. We bring together the right people, irrespective of industries, with depth of talent who will generate value. Together as a one team, we enable you to navigate the ever-changing landscape, achieving more with the use of FSM and ERP services. We are professional, committed, and the experience we have is unmatched on taking the customers and helping them to reach the full potential. The battle stars are ready. Jumpstart your FSM and ERP transformation. Accents.
A very good evening to all of you, and I welcome you to the SLASCOM Tech Together webinar series organized by the Regional Development Forum of SLASCOM. This is a monthly webinar series organized for the third consecutive year that is aimed to provide insights to the next generation of the industry and to equip them with the knowledge on various aspects of the IT and BPM industry. Today, we are hosting the fourth webinar of this series. I'm Rukshila Fernandopulle, your host this evening, and we join you live from Vital Hub Innovations Lab, Colombo. Our topic for today is Introduction to Docker and Kubernetes. We would like to say a special thanks to our sponsors of this series. As our platinum sponsors, we have LSEG and Vital Hub Innovations Lab. And as our gold sponsors, we have on board Pearson, Oral IT, and Accents. Without taking much time, let's move into this exciting session. Stay tuned as you have a valuable opportunity of participating in a quiz and winning a valuable prize as well. Without further ado, let me introduce our speaker for the session. We have with us today Mantila Mendis from Vital Hub Innovations Lab. Mantila is an experienced engineer with a demonstrated history in the information technology and services industry. Skilled in DevOps and cloud, he is a strong engineering professional with a bachelor's degree focused in computer science and networking from SLIT. Thank you, Mantila, for joining us today. This session is now over to you.
Thank you, Rukshila. So let me share my screen. Okay, so today we are going to briefly look into the tools called like Docker and Kubernetes and how we can use them in a like advantageable manner in the industry. So let's first look into Docker. So normally in the industry, there can be requirements like to set up a end-to-end application stack. So when you mention end-to-end application stack, there can be several components like web servers, databases, messaging services, and orchestration like configuration management tools likewise. So when you have to do a setup like this, there can be a lot of issues that occur while you set it up. So especially when you try to set it up in a single environment. So those like if I go to the next slide, you can see that when you set up a component on a system, there are a lot of dependencies to libraries, and there are other component dependencies in a system. So, and also there can be operating system level dependencies. Sometimes, let's say we are setting up a Node.js application. The Node.js application that you want to run on one operating system may not support on that operating system. The MongoDB, if the database is MongoDB, it might not support running on that same operating system. So likewise, if the other tools as well might face those issues when you try to set up this kind of infrastructure. So even let's say after you set the environment without any issues, and you wanted to do an upgrade on your system or for your application, and when you try to do the application, there maybe it can be a database related application and you wanted to do a database upgrade, then at that time you might face issues again. So when you consider these kind of issues, these issues were already there in when people were trying to set up new things. So one solution that people came from these issues to overcome these issues is containerization. So when the reason behind what is the reason behind coming to containerization was the ability that containerization gives to the user to update a component without impacting the other component inside a container. So what does that mean is, with containers we can modify each component without doing any harm to the other component, and we can do any changes to dependencies like libraries or any other dependencies inside the container on the same server. Like previously we said that in the same server we encountered issues, but when you are using containerization in the same server, you can overcome these issues. So if to use Docker, to use an environment like Docker, a containerized environment, what you need to do is just have the Docker software running on your machine. That's it. So before going into more to the operating containerization, I like to say a few things about operating systems, how they work. Like in this, during this today's presentation, I'm mostly focusing towards the Linux operating systems. So Linux operating systems mainly has two components. One is the OS kernel, and the other thing is the software that runs on top of that. So the responsibility of the OS kernel is it is always communicating with the underlying hardware, interacts with the underlying hardware, and for the Linux distributions, this OS kernel is same for all the Linux distributions. And so you know that there are a lot of distributions like Debian, Fedora, and then CentOS, like So all these distributions, the kernel is same, but it differs from the software that runs on top of it. So these software differentiate the distribution by the interfaces, drivers, compilers, and other file managers likewise. So among all distributions, they have the common kernel, Linux, and different software on top of it. So now I'll come to containers. So now if you look at the container is an isolated environment on where it has its own processors, it has its own network, and it has its own mount points. So except that if multiple containers are running on the same server, it shares the kernel of the underlying operating system. So in the screen, you can see that there are a couple of on the right hand side there are four containers running on top of Docker in a server, and these processes are isolated from each container. The one process running on one server cannot be seen by another process running in another container. Likewise. So on the left hand side, you can see the stack of the containerization. So we have the underlying hardware. On top of that, you have the operating system. Here we have a Linux-based operating system. And on top of that, you have to run the Docker software on it. And on top of that, we can spin up containers. So since Docker containers share underlying kernel, Docker can run any flavor of OS on top of it as long as they are based on same kernel. So each Docker container only has additional software based on the operating system. So any distribution can work with different software. So any distribution that you share the kernel can run on top of Docker because of this reason. But there we when it comes to Windows, we cannot run Windows-based containers on top of Linux-based kernels because Windows operating system does not have the ability to share the kernel. So if I give a brief summary, so a system with, let's say you have a system running an Ubuntu operating system, and on top of that you have a Docker software installed up and running, and you can run any flavor of operating system on top of it as long as it is based on a same Linux kernel. So if the underlying operating system is Ubuntu, then you can run any distribution like Fedora, CentOS, SUSE, any kind of operating system inside a container on top of that. So this is a brief summary of VM and a container, because containers are most likely behave like VMs, except that in a VM you need to install operating system for each and every VM, and on top of that you need to have the libraries, dependencies, and stuff like that. And for each VM there's a separate kernel, but in a containerized environment on a single server you can have multiple containers where there's only one OS kernel is shared among the containers. So if you if I describe about hypervisor, is the one that normally we spin up VMs on top of that. Hypervisor is a special software that have the ability to create and run virtual machines. So next about Docker, when we talk about Dockerization, we need to talk about images and how images become containers. So image is a package. Image is a software that it's like a software package that we use to create on top of some of the given instructions. So in the industry, let's say we want to host an application, what we do is we create a specific file, and in that file we give the specific instruction how our package should be created. So when that package is created, we can create multiple instances, multiple containers from that package or the image. So in the diagram, you can see that where we have created one image, and from using that image, we can create multiple containers using that. So containers are running instances of an image. And so I told you that we have a special file that we use to give this instruction. So that file is called a Docker file. And in that Docker file, we give the instruction. And when we want to build it, we give Docker build commands. Then once it is built, we can use it to run on a given environment. So another important thing when we talk about Docker is a Docker registry. So Docker registry is actually a storage location. It's a scalable storage where we store our images that we create. And also it gives the ability to do the version controlling so that we can have a lot of versions with different images. So if, I will do a small demonstration, and while doing that, I will describe more how we can use a Docker registry with those abilities. So I will go do a small demonstration so that you will get a more brief idea about what is Docker. So when we are working with Docker, there are specific commands that we can use. So let me share my screen. Let me share a small demonstration session and do those commands. Now I'm trying to connect to a server that has Ubuntu operating system installed, and on top of that, I have installed Docker. So how I can check whether Docker is installed is I can run the I can give the command Docker, and it should give a message like this. So when you connect to a Docker environment, you can check whether any containers are already running. So the command is to give Docker PS, and if there are any containers running, it will show you. So we can see that this is a new environment and we haven't done it. So if you want to just simply run a container, what you have to do is give the Docker run and give the name of that container. So let's say you want to run let's say a web server, you want to spin up a web server, then you can give Docker run nginx. So what you are seeing is it will try to see whether the nginx is available locally. Now, if you see that nginx is not available locally, so it is pulling it from the nginx repository, the public Docker registry. So once it's pulled, now you can see that Docker, the container is running. So to double check that, I will give the command that I previously given, Docker PS. Now you can see that the output is different from previous. I'll zoom it a bit so that now you can see that previously when I put the Docker PS command, it was not running, but now you can see it's running. So now I'm going to close this, end the container. Now if I again type it, you can see now it's not there anymore. So now let's say I want to connect to this Docker container. Then what I can do is Docker run nginx. Then I want to expose this using a port. So normally this container opens a port 80 since nginx opens port 80. So I want to bind it to my server. Then I will run it again. And if I again press Docker PS, you can see Now it's running and it shows that port. Previous one, you can see that only it shows port 80 is open, but now it's forwarding the traffic to my machine's port 80 because I gave a different command to like -p. -p is to forward the traffic to my machine. So now I can test this actually. How I can test this is I'm going to copy my, this is the public address of my server. Now, can you see? It's that simple. If you want to spin up Nginx server, what you have to do is just run Docker Nginx and exports the port to the port of the server. So I will do another small change and show you how easily we can do some changes. So now I told you that there's a file called Docker file where we can give the commands, specific commands. So I will show you a Docker file that I created. It's a very simple file. So in this Docker file, I'm saying from engine, use the Nginx base Docker image and copy this index.html file to the base location Docker document root of the server. So in the Nginx, there's a document root to host the files. So now I'm going to build this Docker file. So then when we are building, we can give a tag. So for the tag, I am giving so now you can see it built. Now it uses Nginx. This show that step 1 and step 2, the copy the index file. So now once if it's successfully built, it will give this output, and if it's successfully tagged, it will give this output. Now I want to see whether my image is there. Yes, my image is there now. And let's say I want to run this image, so I can do same thing which I did. Docker run minus okay. Now if I give the command, I can see that my content is running, and now I'm going to check it. Can you see? Now it's showing a different output because I copied my index.html file, which includes this content. So that's how we create an image. This is a very simple image. So this is how we can create image. So next thing is, now when I was tagging the image, I gave a special tag. So in that tag, in that tag, I given month 24 and month 11. So here, this is the month 24 means the repository name. So repository means in the Docker Hub, I have several repositories. So my repository is my repository name is month 24, and I have a image name called month 11. Sorry, my account is month 24 and my repository is month 11. That's why I gave it like that way. So if I go to month 11 now, there's only one image, one tag still. So let's say I want to push it to my private repository. What I can do is Docker push. Okay. Now it says it pushed. Now if I go back to my repository, if I refresh it, there should be another version. So now anyone who access to my repository can download this container and run it anywhere they want. So this is the cycle, how we can use Docker in the industry or when we want to set up an environment. So this is so if I want to say, let's say I want to again build with a different, I want to do a small change rather than hi Mantila, I want to change it to hi Mantila Mendes. Then what I can do is I can change it, give a different version, or else it will overwrite with the previous one. Then tag it with a different version number and then push it, just like what we did earlier. And if I want to run that, what I have to do is just put 2 and run it. Then now when I browse it, rather than Mantila, it should show hi Mantila Mendes. So now if I go back to the registry, you can see that there should be another new version, a new image is available with a new version. So this is how we can use Docker. So this is a very high level, I described it very high level, in a high level manner to get an idea how Docker is used. So I think for the first part, the demonstration is that's all for the demonstration. I will hand over to Ukshila.
Thank you, Mantila, for that informative initial session on Docker. So we'll get back to this conversation after a few quick messages from our Platinum sponsors. So do stay tuned with us until the end so that you can participate in the quiz and be a winner as well.
LSEC Technology, solution provider to financial market institutions around the globe. We provide trading, surveillance, clearing, depository solutions to over 25 institutions spread out over 5 continents.
Innovation is the legacy and the foundation of our success and will continue to be a key success factor in our future as well. We are a niche, high-performing organization with world-class talent. We attract the cream of the system in the country.
LSEG technology products win in the market due to its technical competitiveness. That is, we are a few years ahead of the competition in terms of technology. To preserve our competitive advantage, we do invest in keeping our developers abreast and up to date of all the current technologies so that in turn our products are extremely competitive in the marketplace.
We belong to a fabulous legacy which has changed year on year to be completely new, current and different. So all of us who is in this organization now and somebody who is a potential family member has an opportunity to shape, navigate, envision what it ought to be for the next centuries to come.
We have operated this company in Colombo for the last 15 years. We started in 2007, staff of 4 people, supporting 1 core product, and we've now grown to 85 people, supporting 15 plus products using various different modern technologies. We develop software for export only. This has given us an opportunity to bring in a steady flow of dollars into the country every month. We believe in giving university students an opportunity to work on real-world projects. As a result, we have built a very robust internship program. We have successfully implemented several CSR projects over the years. particularly focused on gender diversity. We have a very relaxed global one-office culture. We have standard HR policies across the board. We believe that respect must be shown to all fellow employees, regardless of geographic location. We believe that face-to-face interactions are very important in building business relationships. As a result, we regularly promote two-way travel programs and make it available for all of our staff on a regular basis.
So welcome back, everyone. You are joining us live on the Tech Together webinar on Introduction to Docker and Kubernetes, organized by the Regional Development Forum of SLASCOM. So Mantila, back to you to continue.
Thank you. Okay, so now we look into the Docker session, how Docker is used, and now let's look into what is Kubernetes. So Kubernetes is built by Google. So the reason behind Kubernetes was the experiences they had while they were working with containers. So there were a couple of issues that they had when they were running containers in the production. So how do you run a container in a production environment? So we looked into how we create containers. We run in normal a simple environment, but when it's not that easy to run an application on a production environment. So when we are running a application in actual production environment, it can rely on other containers as well, or any other third-party services. So maybe some databases or any other queue services which are also running in as containers. So, and also let's say that what if in the production environment suddenly the load goes up and you want to scale the cluster, you want to scale the number of containers running, and or when again the load goes down, how can you scale down that? Likewise, there were a lot of concerns that they had. So this is why, so to make sure that we overcome these problems, this is where that's where they needed the underlying platform with those resources and other capabilities, so that we can orchestrate those, like make sure that everything runs, scale, and give the high availability to the production applications. So this whole process of automatically deploying and managing is called orchestration. So this is so now if we now there are actually a lot of orchestration tools like Docker, Swarm, Kubernetes, and Apache Mesos. Those are some of the popular ones. But from these, at the moment, Kubernetes is the most popular and best in the market. So with Kubernetes, it gives several features and give advantages for the for a application. So if your container is deployed on top of Kubernetes, then application is highly available. So how it highly available? Because when we set up a Kubernetes, we set it as a cluster. So in a cluster, there are several nodes. So because of that reason, there's a capability of giving the application a very high availability. Then in a Kubernetes cluster, we can have a lot of containers, not a single container, and they are in a distributed manner. So for these distributed containers, the traffic is load balanced when we have orchestration tool. So that is handled by that orchestration tool. And auto scaling, very important. So we know that not every time the load of a server is same. sometimes during off-peak hours it goes down, as well as during peak hours it goes high. So we need a mechanism to automatically auto-scale the application. So if the load is high, increase the number of containers. And if the load is low, decrease the number of containers. Even beyond that, Kubernetes with automated Kubernetes environment, managed Kubernetes environment, it gives the opportunity to like automatically scale the cluster as well. Even if it's not, if it's a on-premise Kubernetes cluster, we have the ability to add new nodes. If the load is going high, we can add a new node and increase the number of resources. Like let's say our customer base is improved now. Previously we were serving only 10 customers, and this year we have 50 customers. Now we need to run most containers at the same time. So we can add a new node to the cluster and make sure that more containers are running and they are distributed among the cluster so that more customers can connect. So likewise, there are a lot of advantages when we use an orchestration tool for Dockerization with the containerized environment. So when we talk about Kubernetes, there are, in Kubernetes, we have nodes. So node is a physical or virtual machine where Kubernetes software is installed. And on top of these nodes, the containers are launched. So when we are setting a Kubernetes environment, we never, especially in production environment, we never set it up in a single node. So that's where the Kubernetes cluster comes to play. So what we do is we spin up more than one node, and altogether it will become a cluster. So as you can see in this diagram, if you have a one node, then if this node goes down, then the applications running on that will go down as well. So, but if you have a cluster like this, you can have multiple containers running. So you can have the same container with 3 replicas in 3 nodes. So then if one node goes down, the other 2 are still there to serve your customers. So in a Kubernetes cluster, there are 2 types of nodes. One is master nodes, the other one is worker nodes. So master node is also just another node which is responsible to manage the cluster and keep information about nodes. When a node fails, how to move the workload or fail nodes from the fail node to other nodes, and those things are managed by the master node. So master node always keep track of the cluster and watches for the other nodes, whether the status of the other nodes, and if a node goes down, then quickly move the nodes, the work containers from that node to a different node likewise. So the responsibility is always in the master node. So the other worker node type is the workers node type is workers. So this is where mainly the containers run, your applications run. What you deploy on top of Kubernetes runs on these workers. So in the workers, a container runtime has to be run. So container runtime, in this case, we are using Docker. So on top of the container runtime, the containers are running. So in worker nodes, there's a service called kubelet running, which is always communicating with the master, and that's how the master node get the information about the worker nodes and the cluster, the information. So that's the high-level architecture of how the Kubernetes cluster. So there's a master node is there, and there are worker nodes. So actually, you can have more than one master node as well to a high available environment. So in this diagram, you only see one master node, but if you want, when in a production environment, it's a best practice to have more than one master node. So normally we have 3 master nodes. So in case if a master node goes down, the whole cluster goes down. That's why if there's only one master node. So if you want to have high available, you should have more than one master node. So in a Kubernetes in cluster, there are a couple of important components. First one is the API server. So API server is the front end for Kubernetes. Kubernetes users, the management devices, CLIs, everything. So when if you want to deploy an application to Kubernetes cluster, you are directly communicating with this component. And the next important component is the etcd, which is a storage, a key value pair storage, which used to keep all the information that to manage the cluster. All the cluster management related information is stored in this. So another important component is a scheduler, which is responsible to schedule, like distribute the workloads. So workloads mean the containers. Scheduler is the component that distribute containers among the cluster. So depending on the resource availability and stuff, it will do that. So another important component is a controller. Actually, this component is called the brain behind the orchestration. So because it always keep track of the containers and all the endpoints of the cluster. And if anything goes down or if anything happens to the containers, this is the one who take the responsibility and make sure that a container is again restarted or moved to a different node, and those things are handled by this. So as I described earlier, also a container runtime, which is the underlying software used for the containers to run on top of it. Then also the kubelet, which is the agent that runs on all the nodes that used to communicate with the master and worker nodes. So like if you check the master and worker node, on the master, the Kube API server is running there, etcd server is running there, controller, scheduler, all of them are running on master nodes. And on the worker nodes, the containers are running on the worker nodes. And also when we talk about Kubernetes, this is the main component, a main tool, which we call kubectl. It is the command line tool to communicate with Kubernetes clusters. So let's say if you want to deploy an Nginx application on top of Kubernetes, what you have to do is connect to the Kubernetes cluster and run a command kubectl run Nginx. Then simply it will deploy that, run the container on top of Kubernetes. So if you want to get cluster information, this is the tool that you have to use. If you type kubectl cluster info, it will give all the details about the cluster. So this is the main component that we use to communicate with the cluster. Okay, so now I will go to another demonstration so that you can have a more clear idea about how Kubernetes is used with containers. So now if you can see my scene. Can you see, like, when I type cluster info, it gives me some information here. And if I type so in this cluster, I am running, there are 2 worker nodes. Sorry, 2 worker nodes are running. Here, since this is a managed Kubernetes cluster, the master node is not there. Master node is an external service, but if you have a private Kubernetes cluster, then it will show you the master node specifically here, saying the role is master. So now let's say I want to deploy an application to Kubernetes. How can I do it? Now I think you can remember that I created the image in the previous session, in the previous demonstration session, using Docker. Let's say I want to deploy that container here. How can I do it? So what we have to do is, you need to create a file. So normally when we are communicating with Kubernetes, we can use the file format called YAML. So in a YAML file, we can define how we want to deploy an application to Kubernetes. So here I have defined a deployment. In this deployment, I give a name to the deployment and I give a label, and then I give how many replicas. Replicas means how many containers that I should run on top of Kubernetes. So then after that, I need to give what is the image. So now you can remember that my account month24, I deployed an image called Monthila with a version called, let's say, first I deployed it version 1, number 1. So then I need to give the port that now you know that as I described, I use Nginx and it opens a port 80. So I define the port as port 80. And so this is a private repository. I need to give a credential from how I can get that get the authentication to the registry and download the image. So I already configured the authentication. I created a secret for this, and that secret name should be given. So then if I give apply minus and this is how we create a deployment. We can give the apply command and -f for the file, the name of the file, then we have to give. Okay, now you can see that deployment is created. Now how can I check it? So if I can check, there's a command called pods. When in Kubernetes, the smallest component is called a pod, and inside the pod, the container is running. So in a pod, we can actually define multiple containers. So in this pod, we have only defined one container. So if I to get the information about the pod, I can say, let's get the deployment information. If I say get deploy, it says that I have done one deployment called Monthila deployment, and there are one pod is running. Then let's say what are the pod details? So I can see that the pod is running. So let's say that I want to test this. There are a couple of ways. One is Kubernetes itself provide option to port forward the traffic to your local machine and test it. So if I do it, then I have to give the port. I want to forward to port 8080. The container's port is port 80. Now you can see that in my machine to this port, it's redirecting traffic. So if I go to the browser again and check that, now you can see that the 001 version is there. Okay, now let's get back. Let's say I want to expose this using a load balancer to publicly access this. Then what I have to do is there's a component called service in Kubernetes that we can integrate with the deployment, and it will be used to expose the traffic to external network. So I have already defined it. So you can see it's a very small file. What you have to do is you have to match this selector with the label that was defined in the deployment, and then give the related ports, and also mention what type of service this should be. So I want to make a load balancer because this is a publicly I'm going to publicly expose this. So just like I did for the deployment, I'm going to apply it. So the command to check is kubectl get SCC. Now you can see it has created an external endpoint as the type load balancer. So also there's another command called describe in Kubernetes to describe a service with lot of in more details. Okay, you can see that it will give some information here. So from this information, we can see whether the load balance is created. Yeah, the load balance is created. With this command, you can make sure. So we can test this. So what you have to do is go to the browser and paste this endpoint. Seems like it's not created there. Wait for some time. It's created. Ah, yeah, it's up. Can you see? So that's how easy it is. So let's say now we have new features to implement on the new server, and we want to deploy the next version. So what you have to do is just edit the deployment file. Just simply change the version. And apply it. You can see that it has deployed 5 seconds, the range is. So now if you refresh this, can you see it's changed? Now it's showing high month 11. So if you want to revert back, you just have to again change the version to the previous version. So that's how easy when we use a containerized environment and with Kubernetes. So I hope you got a brief idea about how the containerized environment can be used and how you can orchestrate on using with the facts that I have provided you today. So that's it for today's session from my end. So I will hand over to Rukshita.
Thank you, Mantila, for your insightful session to our undergraduates this evening. So I'm sure now they have an idea on how Docker is used with Kubernetes, and they'll be able to use this in their future projects as well. So now let's move on to the much awaited quiz. The link to this quiz is available on the chat box, and you can drop in your answers now, so you can keep your answers coming. And also don't forget to check out the complete quiz, which is available on the SLASCOM Academy platform. The link of that is also shared in the chat box. So you can challenge yourself to answer all these questions. So while we await the winner of this quiz to be displayed, maybe we can take a few questions from our audience. You can share any questions which you have on the chat box. We have already received a few questions. So let me take the first question, Mantila. Can there be any security issues if we share the same host between many Docker containers?
It's like this, like when we spin up a Docker container, it's an isolated environment. Like from the Docker container, you cannot directly access the underlying OS files unless it is mounted from that mounted on top of it. So, but they are like if a person like if a hacker or anyone tries to go into the Docker container, then he might not be able to directly do any changes because he's in a virtual environment, like container environment. No. So he does not have access to the underlying operating system files. So I hope you get an answer for that. But if the files are being used on the underlying operating system, there can be a security risk.
Okay, we hope we answered that question. So we can take another question. Will you lose your data when a Docker container exists? Mantila, maybe we can answer that as well.
Not actually. Like it's like this: when a Docker container exits, still the container remains there. For an example, I show you. I'll quickly share my screen. Like, can you remember Can you remember that we ran some Docker? So if let's say if I stop this container, now it's not running anymore, right? But if you check Docker ps-a, you can see they are still remaining on the server. So if you want to get that container up again, what you can do is just give the image container ID of that and again type docker start and give the container ID. And then at that moment, the container will start again. Then you can actually log into the container. And if you want any information from that container, you can get it from there.
Thanks, Mantila, for answering that as well. So we'll be awaiting the winner of the quiz to be displayed on the screen very soon. Okay, so yes, we have a winner for today. It's BSH Pahasara. So congratulations, Pahasara. You'll be contacted by Slaskcom regarding your gift very soon. So with that, we would like to once again say a special note of thanks to our sponsors. As platinum sponsors, we have LSEG and Vital Hub Innovations Lab. And as gold sponsors, we have Pearson, Oral IT, and Accents. We appreciate your support towards this webinar series. The next webinar session of Tech webinar series organized by the Regional Development Forum of Slaskcom will be on becoming a professional software engineer. So this is scheduled for the 2nd of February. We hope to see you then as well. So once again, a special thank you to our speaker of today's session, Mantila Mendis. We are very grateful for you for sharing your knowledge with us this evening. And thank you to everyone who joined us today. We hope you have learned and enjoyed session today.
Hello.
We hope you have a pleasant evening. Thank you.
Hello. Hello. Hi, Mantila.